Hello everyone, welcome to yet another video of electromagnetic field series. So in the previous video we have seen about what are the sources and effects of electromagnetic fields, what is mean by electromagnetic fields. So we have discussed about the basics of electromagnetic fields. So in this video we are going to discuss about what are vector fields and vector calculus, and this forms the basis of electrical engineering. So electromagnetic field subject or electromagnetic theory subject is the fundamental for electrical engineering, and it includes vector fields, and also there are few mathematical calculus which involves this vector fields that we are going to discuss now. First, let's see what are vector fields. We know that there are two different terms which are very much aware. One is scalar field, the next one is vector fields. So we can classify fields into two. One is scalar and the other one is vector. Scalar fields are quantities characterized by magnitude only and by algebraic sum. If I have two masses, it is a good example for scalar field. If I have two chapels, it is a good example for scalar fields. If I take this any object or any parameters like temperature, pressure and all, they can be represented in a magnitude value, but you cannot say the direction. There is no direction, you don't have any directions, it prevails everywhere. That is what scalar field is all about. So it is a quantitized data of magnitude and the magnitude only and the algebraic sum of these fields that can be easily understood by the scalar field. So a good example for scalar are atmospheric temperature and pressure. Next comes the vector field. The vector fields are quantities characterized by both magnitude as well as directions. So these vector fields has both magnitude and directions. For example, if you take the speed, if you ask the speed of the bike when you are traveling, they will be telling I am traveling at a rate of 550 kilometers per second, 40 kilometers per second and all, which means that it gives a magnitude value, and you can also say in which direction the bike moves. So it is a good example for electric vector field. So here in this slide we have seen about few examples of vector fields, which are nothing but wind velocity and gravitational force in atmosphere. Now we will see what is meant by vector. Vector is represented by arrows, because let A be a vector. Okay, if I want to represent it as vector, means I have to write an arrow above the term, which means that it is a vector, it has both magnitude and directions. So these vectors are represented by arrows, and these have magnitude of length and also it has a direction. And this vector can be expressed in terms of these two properties, the length and the vector direction. Now we will see what is meant by unit vectors. So unit vectors are vectors which has only magnitude and no directions. So if we are very much aware of the scalar quantities and you have done a number of operations using those scalar values, but what we actually this EMF is all concerned about is the vector fields. Any vector can be expressed as a scalar multiple of its unit vector. So if you get through the picture, you can easily understand about how this unit vector will be. So unit vector will be for example, in the given image you can see three coordinate systems which are named after through terms like x, y, z, and these unit vectors are represented by OA, that is the unit vectors from the origin point O to the point A, and since it is in direction A, it is given by A cap. The line or the arrow above the unit vector can be told as cap. So the unit vector OA cap is equal to OA divided by mod OA. Now let's see the other terminologies in the scalar and vector fields. So a vector field consists of position vector, and then it has design vectors, and then you can make calculations with that. So let's see about what is meant by distance vector. First we have discussed about distance vector, and then now we are going to see about position vector. For example, if you are in a class of 60 and one day if your faculty asks you to come and sit in the class, and you have to tell the location of your place, how will you tell? You will tell the room number, and inside the room number you will tell my place is in the second row and in the third table. So you are giving some position to the place or to you where you are. That is what position vector is also about. If I say a point in y-r axis, it means that it has different positions along with the vector. So r vector is equal to xi plus yj plus zk. So this I, j, k are the result of these three coordinate systems. And then now we can see about the distance vectors. You have 2 points, 2 position vectors, and you find the difference between these two means you will get to know about the distance vectors. Yes, if I have 2 quantities, one is p, the other one is q, and p can be written by p can be represented by xi ai vector plus xy ay y vector plus zy can ax vector, and the other position vector is q vector, which is given by x2 ax vector plus y2 ay vector plus z on az vector. So here how we can find this distance vector is that we have to subtract both the values. So pq is the distance between these p and q is given by pq divided by mod pq, the formula which we have seen already. Now we will see about vector calculus, which is nothing but in vector calculations we have basically 4 things. One is addition, subtraction, then multiplication, then dot product. So there are several different processes that can be described as vector multiplications, but there are scalar multiplications also. But the great drawback is that they are always to multiply or to 2 vectors together. So using this vector multiplication, we can easily multiply 2 vectors, and there are 2 different products, products for this vector multiplications, which is the dot product and cross product. So we can multiply 2 vectors, or we can multiply 2 scalars, or we can multiply a scalar with a vector or a vector with a scalar. Now we will come to know about scalar multiplications. So basically, when a vector is multiplied by a scalar, that is any number or any length or temperature and all, it is being multiplied by the number of times that are being come to existence. So when a vector is multiplied by a scalar, that is a number, its length gets multiplied. And also, now we come here to the important topic of multiplication of vectors. The first one is scalar multiplication of a vector, and the second one is dot product multiplication. Third one is cross product multiplications. So in the dot product multiplications, those two vectors are officially being multiplied, which makes the vector into a scalar. So a dot product takes the first word's component along with the prediction of the second vector. So it then makes the length of that component and multiplies it by the length of the second vector. The third important one thing is cross product. So the cross product is an operator between two vectors that reminds another vector. Specifically, it takes the length of the component of the first vector in direction to the direction of the second vector. Yes. So using this cross product, the resultant will be a scalar. That is one thing you all needs to identify, so that we can be very much aware of this dot product and cross product, because in this upcoming classes we will see a lot of problems which are basically given by these dot product and cross product. So hope this video is very useful. In the upcoming videos I'll catch you back in an exciting topic. Thank you. Thanks for listening.